So this is going to be your introduction to chemistry. So we want to make sure that we have our notes ready because there are going to be notes that we need to take. Now I won't be drawing out and writing out exactly what you need to write down, so this will be really good practice for you to figure out some of the shorthand forms that you have created or need to create to take quicker notes. Of course, you can always pause the video wherever you need if you need a little more time to write anything down. We're going to be talking about energy systems and how that affects matter. Now, there are inputs of energy where energy is being added to something and its energy level is increasing. And then there are outputs of energy, and that's where energy is being lost or released. Now, previously, you should have learned the law of conservation of energy, which says that energy can neither be created nor can it be destroyed. It can be changed, it can be transferred, and it can be moved, but you're not going to create energy out of nothing, and you're not going to be able to destroy it forever. There's a similar law that we're going to focus on in 8th grade. It's called Law of Conservation of Mass, where matter cannot be created nor destroyed. It's very similar to the law of conservation of energy. Now, you can move matter around, you can take molecules that make up matter and you can combine them or destroy them or break them apart in a chemical reaction, but you can never completely get rid of matter, and you cannot create new matter out of nothing. One of the most common types of energy to talk about is thermal or heat energy. And we use heat in 3 ways to have it moved around. We could do conduction, which is thermal energy being transferred between particles through an object. So when you put a pan on the stove and you start to heat it up, you're going to feel the bottom of the metal get hot first, and then slowly that heat will start to spread throughout. You could also have heat distributed through convection, and that's moving air typically. So that's a lot of the ways that our houses are warmed up. You have an intake, which takes cold air out of the room, it gets heated, and then it blows into the air and it circulates. Hot air wants to rise, cold air wants to sink, and if you can get that circulation going, you can distribute that heat energy. And then the last way is through radiation. Radiation is done through waves. So if you were to stand next to what we would call a radiator or next to a fire, you could feel the heat radiating off of that heat source. So you're feeling the heat as it transfers through the air in the form of energy wave. Now, energy can be moved around and transformed in different ways. We can do this through physical changes or physical processes. That would be like a change of state of matter where you take a solid and it becomes a liquid, or a liquid evaporates and becomes a gas. It's still the same substance, but it is changed due to the fact that you have introduced heat, or if you went in the opposite direction, you were releasing heat. Chemical processes are a little bit different. You're actually transforming the energy into something else or using it in a new way. You're taking things like energy that's stored in chemical bonds or the arrangement of molecules, and then you're potentially adding those two atoms together so that they combine to make a molecule, or maybe you're splitting them apart. And we can observe different chemical processes by looking for certain signs. We actually represent chemical reactions by a chemical equation. So we're going to be looking a lot at chemical equations. Chemical equations have to be balanced, which means that however many atoms that you have on one side of the equation, you have to have the exact same number on the opposite side of that equation. Think of it as like a math problem where the numbers you have on the left side need to be able to equal the amount of numbers that you have on the right side, right? That's how we do a math equation. Chemical equations are very similar. And remember, this is very important to write down. The law of conservation of mass says that atoms won't be created or destroyed in a chemical reaction, which is why we know that the atoms have to add up. That doesn't mean you have the same substance before and after. In fact, you should have a different substance if it's going to be a chemical reaction. So a chemical reaction, what is it? Well, it's a process where a substance, it can be an element, something from the periodic table, or a compound where you've taken several of the elements on the periodic table and added them together to make a molecule, like H2O is water. and it is changed into one or more new substances. So whatever the result is at the end, you have something that is new and different than what you started with. And we'll look at some examples of that coming up later. So we have terms for things that are what we begin with and what we end with. So a reactant is the original substance that you started with. Okay, it's the thing that you have and that you're going to use maybe in your chemistry experiment. The product is what you get when the chemical reaction is all done, and it should be something brand new that wasn't there before. Now, you can have more than one reactant. In fact, you probably should if you're creating a chemical reaction. And you can have more than one product at the end, but you might also end up with only one product. So there's not a defined set numbers of things. So let's imagine that we have a chemical equation. We have some substance A, and we mix it together with some substance B, and there's a chemical reaction that takes place. We put an arrow showing that a chemical reaction occurred, and now the new substance is that A and B together. So the A by itself and the B by itself are the reactants, and they're on the left side of the equation. And then you have AB, and they're combined together. It's a new thing. It's on the right side of the equation. And like I said, the arrow means that that's what we made. That's what we produced. There are several signs to show you that a chemical reaction happens, but you have to be careful. There are physical reactions and changes that look like chemical reactions. So typically you're looking for more than one of these to show that a chemical reaction actually occurred. Seeing these chemical reactions all the time, though. If you've ever been cooking and using fire, you're creating chemical reactions as you cook them and you heat them up. As you're sitting there breathing, respiration, you're actually creating chemical reactions in your body. You're producing carbon dioxide as you breathe out that was not in the air that you originally were breathing in. So what are some of the signs that we're actually having a chemical reaction occur? Well, you could end up with a color change. So that's the first one we want to write down. A color change. And it has to be a permanent color change. It's not something that we could then change back to later. For example, if I put Kool-Aid into water, the water color is going to change to whatever color that, mix was. But if I evaporated the water off by heating it up and I captured the water and condensed it back down, it would go back to being clear. So that is not a permanent color change. Precipitate formation is a little harder to notice, but you basically combine two liquids to make a solid, something that wasn't there before. That one's a little harder and we probably won't see a lot of. Gas formation is a really big one. A lot of chemical reactions will produce some type of gas, and if you have a liquid, you're going to see that in the form of bubbles. Odor, and this is a change in odor, okay? And odor can be good or bad, although when we hear that word, we typically think of it as being bad. But if the smell of it changes, then that could have indicated that a chemical reaction has occurred. Temperature change is also a really big one, and it's one we're going to look at a lot, and you're going to start hearing the terms endothermic and exothermic, and that relates to whether heat was added or removed, and we can measure that through measuring the temperature before and after. And one of the things that we're going to dive into more is a change in acidity. Did it become more acidic, more acid-like, or did it become less acid-like? Again, you have to be aware that some physical changes look like chemical changes, like food colored in the water, that's kind of like what we were talking before, or boiling water looks like there are gases being created when really that's just the water beginning to evaporate and turn into a gas, but it's still the same substance.